Alright, so this problem is find constants a and b such that this function is differentiable everywhere. Now, to solve this problem, we need to know the definition of differentiable. And the definition of differentiable is just that the function is continuous and that the derivative is continuous. So if we can make sure both of these things are true, it'll be differentiable. Now, the first thing to note is that anywhere but x equals 1, where these split, it should be fine. One's a line, one's a parabola, they're both differentiable everywhere. But where they meet, I need these two things to be true. So, the first step for this problem is to find the derivative. So, let's do that. Now, since it's a piecewise function, we just take the derivative of each piece separately. And so, the derivative of ax plus 5 is just a, and that's still going to be for when x is less than or equal to 1. And the derivative for bx squared minus 2x plus 1 is just going to be 2bx minus 2. And that's going to be when x is bigger than 1. Now, let's make sure these two functions are continuous. And the way we do that is we want to check around 1 only. So what I really want to do is limit as x goes to 1 from the left. F of x needs to be limit as x goes to 1 from the right. F of x. Alright, so when I evaluate this limit, if I'm going to go to 1 from the left, I need to pick the part of the function that is to the left of 1. And that's going to be this one, because this is for less than or equal to 1. So, limit as x goes to 1 from the left, ax plus 5 equals limit x goes to 1 from the right. And for this one, I want the one from the right. So that's going to be this one, because this is x is bigger than 1, or to the right of 1. Alright, and now I can just evaluate the limit. So plug in 1 for x. So I get a plus 5 equals b minus 2 plus 1. Or a equals b minus 6. Alright. Now, this doesn't let me finish the problem because I only have one equation, but I have two things I don't know. But as long as this is true, f should be continuous. Alright. So, and I'll just note that over here. Now, the next thing I need to do is make sure f prime is continuous. So, I'm going to do the same sort of thing. Limit as x goes to 1 from the right, f prime of x needs to equal limit as x goes to 1 from the right, f prime of x. Now I'm going to do the same sort of thing as before. So, f prime to the left, well, that's just going to be a. And x prime to the right, well, that's just going to be that 2bx minus 2. Alright. And then now I can just evaluate the limit. Now x is here, so that's just a. And then over here, plug in 1 for x, I get 2b minus 2. So let me box that, and box that. And this equation will make sure that f prime is continuous. So now to finish the problem, I just need to make sure both of these are satisfied. So I need to pick a's and b's that work for both of these. So I'll come over here and erase this because we don't need it anymore, and write down my two equations. I need a to be b minus 6, and I need a to be 2b minus 2. So we just need to solve this system. So I say just set them equal around a. Move a b over and add the 2 over. So I get b is minus 4. And let's just plug that in here. And that'll give me a is minus 10. So as long as b is minus 4 and a is minus 10, this function should be differentiable everywhere.